Hey, good afternoon, Honors Algebra 2. Hope you're doing well. Here to teach you just a little bit today in section 5.2. So write down this objective, pause this video, applying properties of rational exponents. Okay, now we wrote down a long while back, not a long while back, section 4.1. We wrote down every one of these properties. Okay, product of powers, when you're multiplying things with like bases, you add the exponents. When you're taking a power to a power, you're multiplying the exponents. When you have multiple bases in parentheses, they're all being raised to a power, you're distributing that power. Any negative exponent is going to move the base to the denominator, or if it's in the denominator and negative, it'll move it back to the numerator. Anything to the 0 power is 1. Anytime you're dividing things with like bases, we are subtracting the exponents. And lastly, all right, if we have a fraction all being raised to a power, then we're going to go ahead and distribute that power both to the numerator and the denominator. So you already know this. So today we're going to do that with, we're going to use these properties with rational exponents. In other words, it was really easy if it was x to the third times x squared, right? That's obviously x to the fifth. Well, how about this? X to the 1/2 times x to the 1/3. Okay, now this is not x to the 1/6, right? We're not multiplying these, we're adding them. So it actually is, something that we would stumble on if we don't remember our properties, but we're adding 1/2 plus 1/3. And right back to 5th grade, 1/2 plus 1/3, we need a common denominator, 3/6 plus 2/6. This is actually x to the 5/6 power. Okay, we are adding those together. Right now, in property number 2, when we're taking a power and raising it to another power, now we're multiplying. All right, we are multiplying these two numbers, and obviously then back to 5th grade again, 3/4 times 1/2, we multiply right across, and we get 3/8. So x to the 3/4 times x to the 1/2 is x to the 3/8. Okay, so when we are using this property, number 3, okay, if there was a 2 and an x to the 4/5, and we're raising that to the 1/3 power, okay, it's like, okay, what do I multiply this 2 by? Well, the 2 has a base, I'm sorry, an exponent of 1. So 1 times 1/3 is 1/3. That's 2 to the 1/3 times x to the 4/15 is what that would be. Now, people ask, Mr. Hers, do you want us to write that as the cube root of 2? Do you want us to actually multiply, or you actually do that in our calculator and write the decimal version of that? And the answer is no. We leave it in rational exponent form because it started in rational exponent form. Okay, so actually, although it's kind of odd to just write 2 to the 1/3 and just leave it, we're just going to leave that as 2 to the 1/3 x to the 4/15. Okay. Let's see. Let's do a couple that would combine some things together. Okay. So let's talk about number 1 here. Okay. Go ahead and pause this video and write it down. Okay? And the first thing we're going to notice is the 6 and the 3. That's the same as, again, back to 5th grade. 6 divided by 3 is 2. All right, so it's 2 over 1. Now, an x to the first power and an x to the 1/2 power, all right, x is in the numerator, x to the 1/2 is in the denominator, right? When we're dividing things with like bases, we're subtracting the exponents. So we're subtracting 1 minus 1/2, okay, which is 2/2 minus 1/2, which is obviously 1/2. So it's x to the 1/2 power still in the denominator, or excuse me, still in the numerator, right? And the reason for that is because 1 is a higher number than 1/2, so obviously 1 minus 1/2 is still a positive 1/2. It goes in the numerator. Now, this y to the 1/2 and y to the 3/4, you're still going to take, right, here's what I would do if I were you. I would take 3/4 minus 1/2 and just know, instead of 1/2 minus 3/4, okay, I would take 3/4 minus 1/2 and know that whatever we're going to get, we're going to have a y value in the denominator because that power is higher than that power. It's a greater number, so it's overpowering the numerator, and therefore when we divide this, our what's left is going to be in the denominator. Okay, so 3/4 minus 1/2 is 3/4 minus 2/4, which is 1/4. Okay, so this would be y to the 1/4 power. Now, okay, I want to teach you something real quick. Anytime we have a rational exponent in the denominator, okay, that is like having a radical in the denominator. Because remember, taking something to the 1/4 power or 1/2 power is like taking the square root of something. And if you remember back from Algebra 1 and geometry, you can't leave a radical in the denominator and have it be simplified, right? Like the square root of 2 in the denominator, we would do what's called rationalizing the denominator, and we would multiply both top and bottom by the square root of 2. So it would be the square root of 2 over 2. That's how we would simplify 1 divided by the square root of 2. In the same way, if you ever have an x to the 1/2 chilling in the denominator of a fraction, that is the square root of x, and that's not a good thing to have left in the denominator. So actually what we want to do is we want to multiply both the numerator and denominator by another x to the 1/2. Okay, and what that's going to do is you're going to have an x to the 1/2 in the numerator and an x in the denominator. And although this looks strange because now we have like bases in the numerator and denominator, like I should be able to simplify this, it would just get us back to here, which is a problem because this is like having a radical in the denominator. Okay, so I want you to write this: rationalizing. We are rationalizing the denominator here. Rationalizing the denominator. Anytime we have a fractional exponent, denominator. In the denominator of a fraction, we have to do something to get rid of that or to make that go to a whole number, right? And now it's just, this is exactly like 1 over the square root of 2, how that became the square root of 2 over 2. This is exactly what happened with x to the 1 over x to the 1/2. That became x to the 1/2 over x. It literally did the same exact thing that this did, okay? So this is actually simplified. So if you have a fraction in the denominator of a fraction, a fractional exponent, you have to rationalize it. So if we go back to this problem right here, and we have y to the 1/4, we want to take that and rationalize it. And so we're going to multiply something here to both the numerator and the denominator. Now, if we only did a y to the 1/4, okay, you can write this down with me for a sec if you want to, but there's a problem with that. Get rid of this. If we only did a y to the 1/4, then in the denominator when we multiplied, y to the 1/4 times y to the 1/4 is only y to the 1/2. And that does not get rid of a radical in the denominator. So you actually need to think about, like, okay, what are we doing? When we multiply things with like bases, we add the exponents. Well, what's going to add with 1/4 to get me to a whole numbered exponent, which is what I want? And the answer is y to the 3/4 power. I want to take and multiply both the numerator and denominator by y to the 3/4 power. And again, y to the 3/4 over y to the 3/4, that's just 1, right? And anything over itself is just 1. So all we're doing here is we're multiplying this guy by 1. It's just a very well chosen one. Okay, and so in the denominator now it just becomes y, right? Y to the 1/4 times y to the 3/4. You're adding those together and you just get y to the 4/4, which is just y. And then in the numerator you get 2x to the 1/2 y to the 3/4. Okay, so that's tricky because you see that y in the numerator and y in the denominator and you think you need to simplify it, but that would get you back to having a fractional exponent in the denominator, which we don't want. So the general rule of thumb here is that you can kind of tell when you're going to have to rationalize the denominator or not. And if you notice, x to the first, 1 is greater than 1/2. So when you do this simplifying, the fraction is going to go in the numerator. That's just fine. You can have fractional exponents in the numerator. You're way good with that. But 1/2 and 3/4 is more than 1/2. So when we go and simplify this, you're going to get down to a fractional exponent in the denominator. So you're going to have to rationalize that. It's just a good way to see it right from the start. Like, okay, my y is a fraction that's bigger than what's in the numerator. I'm going to end up having a fractional exponent in the denominator. And just know that's going to happen, and that's okay, right? That's just We just have to get to or finish by rationalizing the denominator there. Okay, let's do one more, and then we'll yeah, we'll just do one more here. Okay, 32 m to the 5th n to the 30th, all raised to the 1/5 power. That's 32 to the 1/5. M to the 5th raised to the 1/5 is actually just m to the 1st power now. When we take a power to a power, we're multiplying. And then n to the 30th raised to the 1/5 power, multiply that, and it's n to the 6th. Now the difference between this right here is, well, I'm sorry, last page. 2, where was it? Yeah, 2 to the 1/3 we just left. Why? Because that's ugly. 2 to the 1/3 power is super ugly. But if you notice, 32 to the 1/5, I want you to look at your x to the 5ths on that little chart we made the other day. And 32 to the 1/5 power is actually 2. So we have 2mn to the 6th, right? So this particular section, I'm just gonna cut this video here pretty short and not make you fall asleep. I've already been at it 11 minutes here, but I just wanted you to introduce yourself to all these exponent properties again, which we saw in section 4.1, and how they work with fractional exponents. It works the exact same way. Make sure if you did not get these properties down that you have them all down, and I'll come back on Monday and we'll clear anything up that you might have. All right, assignment and video are posted to your Google Classroom. Oops.